All right, in this video, you're going to see how to mix horizontal shifts, stretches, shrinks, and reflections. All right, so I'm going to show you a couple of different approaches here. And the nice thing about that is that you get to choose the one that resonates the most with you. Okay, so it turns out that there are a couple of pretty strict rules that we can use to help us decide. So what tends to be the most difficult thing about these is deciding on which order. Should I do the shift first? Should I do the shrink first? What should I do first? Okay, so there are some things that you can follow to help take the guesswork out of it. All right, so I'm going to start with a warm-up exercise here that we will use in one of the approaches. So here I have the point 3,2 on the graph of this function y equals f of x. A new function y equals g of x is obtained from y equals f of x by shifting right 3 units, immediately followed by a horizontal stretch by a factor of 2, and then immediately followed by an x-axis reflection. And I want to find the point on the graph of y equals g of x that corresponds to 3,2. So basically I'm going to do all these transformations to the point 3,2, and then that's going to give me a point on the graph of y equals g of x. Okay, so right 3 units, horizontal stretch by 2, x-axis reflection. So the first two are actually in the horizontal direction, which means we perform those actions to the x-coordinate. All right, so we're going to take our x-coordinate of 3,2, and we'll perform the first transformation, which is to shift right 3 units. So shift right 3 units means x is going to be getting bigger. So we're going to add 3 to 3. So shift right by 3 units, we add 3. So that takes us to the point 6, 2. All right, next we have a horizontal stretch by a factor of 2. So that what that means is we're going to take our existing x-coordinate in this step and multiply 2 by that x-coordinate. So that's going to take us to the point 12, 2. All right, so now we have an x-axis reflection. So in an x-axis reflection, everything above the x-axis goes below, everything below the x-axis goes above. Okay, so here the point 12, 2, that has a positive y-coordinate, so reflecting across the x-axis, we'll take it down to 12, -2. All right, so if we were to graph this new function g of x, right, if we actually had an equation or if we had a lot more points, then the point 12, -2 would actually be on that graph. All right, why don't you press pause and find out where the point 1, 0 goes under those same transformations. All right, so the point 1, 0, we first perform the horizontal transformations. So we will go right 3 units, so we add 3 to x. Then we do a horizontal stretch by a factor of 2. So we multiply the x-coordinate by 2. Next, we do an x-axis reflection. So in this case, the point 8, 0 is actually somewhere over here on the x-axis. So when we do an x-axis reflection, it actually doesn't go anywhere. Okay, so under those transformations, the point 1, 0 goes to the point 8, 0. All right, before I get to a general rule of thumb for deciding on the best order for horizontal combined transformations, let's see how we can actually come up with the equation of a function that results from specified transformations. All right, so here we have f of x equals x squared. We want to do a horizontal shrink by a factor of 1/3 and then shift left 2 units. Okay, so shifting left, I think I'm going to add 2. Horizontal shrink by a factor of 1/3 means my x is going to be being multiplied by the reciprocal of 1/3. All right, so I'm going to do it in this order here. So first, my function y equals x squared. I actually need to put parentheses around the 3x. So 3x quantity squared. If I put the 3 on the outside, that's going to be a vertical stretch by 3. I want to do a horizontal shrink by a factor of 1/3, so just the x needs to get multiplied by the 3. If I then shift left 2 units, it means I actually am adding 2 just to x. Or I can think that I'm replacing x with x plus 2. That's the way I like to think about it. So again, it's not just adding 2 to what is there. You're adding 2 to x. This is worth pausing right now, making sure you have that down accurately in your notes. Okay, shifting left by 2, you're not just adding 2 to what's there. X is getting replaced with x plus 2. So it'd be 3 parentheses x plus 2 quantity squared. So that would be the function that we would get by these transformations in this order to that function. All right, so some people are tempted to say that it's going to be, so this is going to be the most common wrong answer. Y equals 3x plus 2 quantity squared. So let's take a look at, as I did in the early example, finding out where points go under a transformation. Let's actually find out where 3 important points of y equals x squared go under these two transformations. Okay, so let's look at the graph of y equals x squared. So again, we're going to investigate. Why does it make more sense that this is the answer than this one? So again, I'm going to graph y equals x squared here. So I have the point 0, 0. I have the point 1, 1. And I have the point negative 1, 1. So I'm going to find out where all 3 of those points go under these two transformations. All right? So I'm going to list them here. So first we do a horizontal shrink by 1/3. What that means is each x-coordinate gets multiplied by 1/3. The y-coordinate stays the same. All right, next we're going to shift left 2 units. What that means is that each of the x-coordinates, we subtract 2 from them. All right, so these 3 are new points. And they're going to be connected in the same way that these 3 original points were connected. So the point negative 1, 1 went to 0, 0, went to 1, 1. So that means this first one goes to this middle one, goes to this last one. So let's actually graph that. All right, so that is what our new functions graph looks like. So the question is this the accurate function? Or is this the accurate function? Why don't you put both of those into vertex form and see which one has the correct vertex of negative 2, 0. Okay, press pause while you work on putting those both into vertex form. So first I'll just, this is 3 times the quantity x plus 2 squared. So I'll square the 3 and then square that one separately. So that property that I'm using would be ab squared is a squared b squared. So that would go to y equals 3 squared, which is 9 times x plus 2 squared. To put this one into the proper form, I'm going to actually factor 3 out first. Sorry, by proper form, I actually should say quadratic form. Okay, so inside these parentheses, I factor out the 3, and then I'll use this property of exponents again. All right, so this one right here, the most common wrong answer, you can see the x-coordinate of the vertex is negative 2/3. It's supposed to be negative 2. This one has that correct vertex. right? So if we look at these two, so the question here now becomes, what's our good rule of thumb? Our good rule of thumb is, here the coefficient of x is factored out. It's 3 parentheses. Here the coefficient of x is not factored out. So let me summarize those results for you. Right? If the coefficient of x is factored out, first you do your stretch or shrink, then you do your shift. All right. If we had the coefficient of x is not factored out, that was the second case. Okay, so 3x plus 2, quantity squared. First, we will shift, then we will stretch shrink. All right, so let me give you an example where you tell me the transformations in the proper order. All right, why don't you press pause and try this one. All right, because the 2 is not factored out, it means we're going to do the shift first. Okay, so first we will, and it's minus 3, so we're going to go right 3 units. Then because of that 2, the 2 is bigger than 1, so that means it's going to be a horizontal shrink by a factor of 1/2. Okay, this next step that I'm going to do is not required, but I know that some people resonate with it. Okay, so once you have your order that you think is correct, you can actually check it off to the side the way I did that last example. So you can say, all right, if I go right 3 units and my parent function is y equals x squared. So if I go right 3 units, it means that in my parent function, I'm subtracting 3 from x, or I'm replacing x with x minus 3. So my function would be x minus 3 quantity squared, y equals that. And then if I do a horizontal shrink by a factor of 1/2, it means x gets replaced with 2x. So it goes to 2x minus 3 quantity squared. And we see that is exactly the function that we were supposed to have. All right, so write the function that results from these transformations. Okay, so why don't you press pause while you work on that one? Again, find the function that results from those. All right, so if we do a horizontal stretch by a factor of 8, it means x has 1/8 multiplied by it. Then if we shift right 1.5 units, it means that we are subtracting 1.5 from the x coordinate. All right, and so you'll see this is consistent with the rule I gave you a second ago. So we expect parentheses when the stretch shrink comes before the shift. So stretch shrink comes before the shift. We will have parentheses before the x. All right, going to give you one last example where you give me the order. All right, so give me the transformations in the correct order for this. All right, the 1/4 is factored out, so we take care of that first. So horizontal stretch by a factor of 4. Finally, we will go left 2 units. All right, so I am ready to give you a rule of thumb here for the general case. So the general rule of thumb will be this. So if I have y equals a times some function eval. So a is multiplied on the outside of the function. So this is now some function whose input is bx plus c, where the b is not factored out from the x, plus d. Okay? In this case, when the b is not factored out, you take care of each of these numbers in the following order. First you do c, then you do b, and b is going to be a stretch or a shrink combined with a reflection, alone, or without a reflection. So b will comprise horizontal stretches, shrinks, and or y-axis reflection. And you can do, so again, B might have two things in it. Among those two things, you could do whichever order you'd like. Okay, we do C, we do B, then we do A. A is the same, so A is going to be a vertical stretch or shrink, maybe combined with an x-axis reflection, maybe not, maybe just an x-axis reflection. But if A consists of two, then you get to do them in whichever order you'd like. Finally, we do D. D is either going to be a shift up or a shift down. Okay, so if B is not factored out, you do C-bad, okay, C-B-A-D. Next, if B is factored out, then first you do B. So B, C, A, D. B, then C, then A, then D. And I call that B, I don't say be sad, all right? We want to be upbeat, be cad, all right? So these are the two rules of thumb for deciding on the order of transformations. All right, so let's put those into play. All right, so I'm going to have, say, y equals 2 square root negative 5 parentheses x plus 2, then outside the parentheses plus 7. Sorry, I drew that a little too long. All right, so pause here and think about what the transformations are in the correct order. All right, this takes the form of the second one. So that means we're going to do the b first, so the negative 5. So the negative there gives us a y-axis reflection. The 5 gives us a horizontal shrink. And we could do whichever of those first that we want, okay? So you can reorder these first two. So I'll say horizontal shrink by a factor of 1/5, then y-axis reflection. Again, you can reverse the order of those two if you'd like. All right, so just as you know, this would give us one followed by the other would give us y equals root. If we stopped there, we would get y equals root negative 5x. All right, so then we shift left by 2 units here because we're taking now care of the c. It's a plus, so we shift left by 2. Next, we move on to the outside, the a there, vertical stretch by 2. Finally, we'll shift 7 units up. All right, I'm going to give you one more of these examples. Okay, so this f is generic. So for example, if f of x were root x, then this would be written specifically as negative root 2x minus 6 plus 2. All right, so whatever you see inside the parentheses, that means that's a horizontal transformation for that function, that random function that we don't have an expression for. Everything on the outside is going to be your vertical stuff. All right, so why don't you press pause while you figure out where this point goes by figuring out the order of transformations here and then applying those transformations to that point. Okay, so once again, find the order of transformations, and then apply to that point to see what a new point would be. All right, so because the 2 is not factored out, we're going to first do the -6, then we do the 2, then we do this negative on the outside, then we do that 2. 2, 1, 6, we're going to shift right by 6 units, so we're going to add 6 to the 2. Okay, so to the x-coordinate. All right, then we take care of the 2, so that means that's going to be a horizontal shrink by a half. So we multiply the x-coordinate by a half. All right, next we have this on the outside, so it's an x-axis reflection. So we multiply the y-coordinate by -1. Finally, we have this +2 on the outside, so that's shifting up 2 units, so we add 2 to the y-coordinate. So add 2 to -1. So 4, 1 would be a point on the new function.